and then observe how the landscape responded to it. So this is the Arctic, you're looking at the Arctic foothills north of the Brooks Range in springtime, and an area that's changing in a variety of ways today. We think that modeling is very complicated to predict these changes, and so we're trying to glean lessons from the past to understand how this system behaves during change. I am at UAF, and my co-authors here are at UAF, BLM, and USGS. Okay, so our main question, as the title indicates, is how sensitive was permafrost thaw and the carbon that's sequestered in this permafrost to past change? And in order to answer that, we reconstructed the climate over the past 15,000 years using a technique of the chemistry of ancient wood, and I'll sort of use oxygen isotopes and chemistry interchangeably. When wood grows, it uses the oxygen from precipitation, and the oxygen isotopes of that precipitation is dependent on the meteorological history of that air mass. Wood retains that signature about the climate that occurred when it grew, and we are using this to figure out what the climate was like in the past and splicing together a bunch of samples to tell us how the climate changed. We're then using lake sediment records as archives for carbon release. When permafrost thaws in a watershed, it releases ancient carbon, and at times in certain areas, lakes trap that carbon and archive it over time in its sediment bed. And so we're comparing our climate and paleocarbon reconstruction over time in the past. At the end of this presentation, I probably should have mentioned a lot of these people are interested in fires, and so we're going to talk about kind of a potential project, how we are interested in incorporating tundra fires into our work, reconstructing tundra fires. So that'll be soon. Just some background. Here's our study area with a bunch of our sampling locations. So this is northern Alaska here, and these are the locations where we sampled ancient wood over the growing from the last 15,000 years, and then many modern willows, shrubs, to understand how climate today has influenced the chemistry of this wood. So this is sort of the calibration data set. Just some background on old wood. We're interested in this because there's a lot of it kicking around the North Slope. You're looking at some black spruce logs that are hundreds of kilometers north of tree line. They're about 125,000 years old. There's also a lot of willow shrubs that blow into lakes, and they get archived over time. This is, you can see my mouse here. These flecks are pieces of willow that are about 10,000 years old. And so the ones above are younger than the ones below. We can radiocarbon date these and then get a sense of their chemistry to infer the past. Okay, but in order to do that, we really wanted to understand how the climate today controls the chemistry of willows, so we sampled a bunch of them across the northern part of the state. And we actually looked at individual rings, the isotopes in individual rings. Here is shown under a microscope. We harvested rings to test how the climate of the year that ring grew altered the isotopic signature, we would call it, of the various wood samples. And so this would be like 2007 right here. So we want to know how the June temperature or the July precipitation affected this ring from that year. Taking a step back, this will then allow us to infer how to interpret the ancient wood that we have these oxygen isotope values on. Okay, so this is just, these are correlation graphs. So this is how well correlated is the oxygen isotopes from the rings. We've got about 200 individual rings from various places growing over the last 30 years. And we find that this is the growing season month of that temperature and then the previous month. And to summarize here, we find the willows use the previous fall's precipitation, and that the chemistry of that precipitation is dependent on the temperature when it fell. And so we find high correlations between these previous fall temperatures, about 0.5 is the value there, and significance levels are 0.01 here and 0.05. We also find a correlation between the previous fall's sea ice as well. And we think this has to do with sea ice moderating the availability of moisture sources from the Arctic Ocean. So to summarize, I know I'm going fast here, but our paleo wood samples can be interpreted as temperature and sea ice, a proxy for those things occurring in the past, assuming the relationships of these things are similar. So that's some background on our paleoclimate work. I'll go into the results momentarily. Some background on permafrost carbon. The reason why we're interested in it mainly is because there's a lot of it. There's sequestered today in the permafrost. It's estimated it's about the same amount of carbon as twice as much as greenhouse gases are in the atmosphere. And the concern is that there could be a feedback mechanism involved. The carbon is sequestered there today because it's frozen. If you warm up the ground and enhance decomposition, you could have greenhouse gas sources and more warming. This is the so-called permafrost carbon feedback. There's Dan Mann right there, bright in front of an old lake bed, and there's an ice wedge right behind him. Okay, so just more background on permafrost. This is probably review for most people, but it sets us up here. So the way permafrost has gotten so much carbon is most of Alaska was unglaciated over the last 2 million years when glaciers spread over a lot of the globe. And so it allowed soil organic matter to accumulate relatively uninterrupted. Here's that in action. This is just a river bluff exposure from the Tiktaalik River on the north slope with some annotations of, and these are the buildup of those soils. So this is 20,000 years ago, and before that, below, this is the accumulation of loess, so that's silt and sand. And here's some more ice wedges here. These build up with the permafrost. Now, the last 10,000 years is represented in this thin veneer on the landscape, and there's your modern day tundra. So bottom line is there's a lot of ancient carbon underlying the unglaciated north slope. And just some context here, I got to throw this in because this is down here is the soils that the mammoths were roaming around on all over the north slope. So it's interesting for many reasons. Okay, so what happens to permafrost and all this ancient carbon when it thaws? Well, we said it feeds into the atmosphere, but it also erodes and ends up downstream. These are some landslides and thaw slumps that have been sparked by relatively warm summers recently. This is along the Anaktuvuk River on the north slope. And so you see that delivery of sediment and ancient carbon to the river, and a lot of the carbon then gets redeposited into these depositional floodplains or lakes. An example of that comes from the work of Don Shell way back in 1983. He looked at the radiocarbon age of various pools of carbon in a lot of aquatic environments on the north slope. So he found that the active layer, the soil that thaws every year, topmost layer. The bottom of that was about 8,000 years old. He also found that because of permafrost thaw, particulate carbon in the lake, that's just basically pond scum that's from the watershed, is about 2,000 years old. And he even shot a long-tailed duck and radiocarbon dated the foot or something, and it was about 1,500 years old. And it's because that carbon was released and routed through the aquatic system. So interesting ages on ducks. For our purposes, though, we're interested in this particulate carbon because it settles to the bottom of the lake and is archived over time. Using this age can tell us how this ancient carbon release has varied over time. So our study area for the paleocarbon work was, we call it Lake of the Pleistocene. It's in the Arctic foothills along the Anaktuvuk River. It's in an ice-rich, unglaciated area. It has a large watershed, which you are looking at there. The lake is a shadow of its former self right here. It used to be much larger and occupy the landscape outlined in white there. The Anaktuvuk River came by and drained this lake about 5,000 years ago. And what that allows us to do is access the lake bluff from this river bluff here. So this is from the air. And so yes, the Anaktuvuk River moved over and eroded out the sill of the lake. And some pictures from, we spent a lot of time here over the last several years, mostly doing a lot of digging in a relatively buggy area, it seems. So I hired some high school students who are at various levels of non-speaking terms with me now, because it's not the most glamorous work. But so this is just thawing out that lake bed to be able to access the samples. Okay, so radiocarbon age-offset, just very quickly, is based, we're getting, this is the lake bed, so the former sediments that are receiving watershed carbon exposed and cleaned off there, and we're getting the true age of when those particular layers were receiving watershed carbon by dating twigs. Those twigs are not reworked, they just blow into the lake, and their radiocarbon age tells us when they were last growing. It gives us a true age of that layer. Whereas the particulate organic matter, so you see the twigs here, 10,800 years old, 8,500 years old. If you date the particulate matter, you get older carbon. That's like our proxy for the duck, the ancient duck. And so that's 12,000-year-old carbon that's being laid down 10,000 years ago. And what the difference of those two is, we call the age offset. That represents the index of how much ancient permafrost carbon was coming out of the watershed over time. So it's the comparison of these things over time that gives us that carbon index. Okay, so I'm going to go into some results quickly. Here's our paleoclimate record of the North Slope over the last 15,000 years. Remember, we calibrated this record with those, think about those rings that I showed you. On the x-axis here is time before present in thousands of years. Y-axis is that Willow chemistry, warmer, less sea ice is up. Cooler times, generally with more sea ice, is down. Each gray symbol is an individual twig or log or whatever ancient wood sample. And so these only represent a few years, each of them, and so there's a lot of variability. So therefore, we have to smooth the record, and you see there's been some dramatic changes and actually the last 6,000 years hasn't seen a lot of changes. We actually don't have a lot of samples in some of these areas. We're still trying to fill this in. What we do see is drastic oscillations between about 15 and 7,000 years ago. These are the deglacial period, we call them, because it's a time where we're coming out of the Ice Age back 20,000 years ago. And so you see these rapid shifts of going up and down, and what the most dramatic of these is this area highlighted in blue. We call that the Younger Dryas period or episode. It's a global cooling episode that was caused by glacial meltwater shutting down the ocean conveyor or thermohaline circulation. So this is potentially a global event. We think it was well expressed on the North Slope. And it's these warming and cooling events that we're testing how the landscape responded. In general, the early Holocene back in here, 8 to 12,000 or 11,000 years ago, is a little bit warmer than today, or a little bit warmer than the last 2,000 years at least. I'll talk about today soon. And this is because the sun's energy in the northern summer was a little bit higher during this time. We can talk about more about this if there's questions later. And so just as kind of a summary of these last 15,000 years and then where we are today, we are at a relatively high point. So here's the modern levels. We're about the same as around 11,000 years ago in terms of the smoothed portion of the record. So not unprecedented, but relatively high. However, I also plotted up the rate of change here. So this is the change in our 018 index per year, and that's that red, based on the red curve, smooth curve. And we see some high and low rates, high rates of change in various directions during these climate oscillations that we are documenting. But the last 150 years, we think that there's a very high rate of change occurring that is probably higher than what we've experienced before. And I think this is actually probably more relevant to sort of biological adaptation and economic societal adaptation. So the big delta here is represented in this curve. Okay, so just some information about the age offsets. This is from a paper we have, came out last year, and this is the last 15,000 years of age offsets. So the true age, those twig ages, is on the x-axis, and how much older the sediment from those layers, from the twigs, is represented on the y-axis. So long story short, going up is more enhanced ancient carbon release into lake of the Pleistocene. And here's that Younger Dryas period in blue. And so we do see enhanced episodes in the past, and then especially around 14 and 10,000 years ago, and then about 1,000 years ago. Again, we're still trying to fill in this portion of the record. And today we are at a relatively low period compared to the past. We look like a relatively cold period today. And I'll talk about in a second a little bit why that may be. In summary, we show that permafrost carbon has been fairly sensitive, but getting less sensitive to the past climate change over time. It's highly sensitive here during this warming event, outlined in orange there, and it's sensitive to cooling as well. However, subsequent warming events like these two, it may have been less sensitive to change. It doesn't go up this high, except here, and we're trying to corroborate this, whether the medieval warm period 1,000 years ago may have been an anomaly of that pattern. And that's culminated into today that you have relatively high 018 values indicating higher temperatures, yet the age offset has not increased. And we're wondering, why is today's permafrost and various events is the landscape desensitized in some way to this. This is obviously important because it may be a negative feedback to that positive feedback. Our working hypothesis for this, we call it the peat buffering hypothesis. It goes that soil organic layers during this relatively warm and wet time over the last 12,000 years, these organic layers have built up over this time period, and they now insulate the underlying permafrost from warming. Peat does a good job at insulation. It buffers from thaw in the summer, and it conducts heat out in the winter. And actually the coldest permafrost or the thinnest active layers are in areas with very thick peat today. And we think that this may explain, we are hypothesizing that this explains why age offsets today are not tracking recent warming and why age offsets during more recent warming events have been less sensitive. Okay, so our idea about what could then influence this peat buffering, which we are trying to flesh out a little bit more, we're trying to understand it over the more recent past, is that tundra fires, if severe, could remove a fair amount of peat and vegetation relatively quickly. And this could remove that negative feedback and make permafrost more vulnerable. And so we would like to test this. This is a tundra fire near Anaktuvuk. There's in northern Alaska, and this isn't a very severe one, I don't think. And so there's not a lot. You can see that some vegetation even survived, and certainly the tussocks were sprouting the next year. So we are wondering how common fires like this were in the past that may not have affected permafrost versus those that were more severe. We know that severe tundra fires, and this is work by Dr. Ben Jones, my collaborator here too, who has worked on using LIDAR, which is a reflection, a very detailed reflection of the surface topography, and this can be used on the tundra to infer thermokarst features. And he showed that during severe fires, you have a removal of peat and a subsidence of ground where ice once was. That network is the former ice wedges that are, well, they're still there, they're just, the tops of them are degrading and subsiding. And he showed that in a recent paper here that I think Eric is a part of too, yes. So this is a very interesting process that we would like to understand more with the context of the past. Our idea for doing this is using charcoal layers in lake sediments, like Lake of the Pleistocene, to infer how common tundra fires were during these past warming events that we now know about, that we have now quantified with the Willow record, and then test whether age offsets were enhanced after fires to test the permafrost carbon response. And so you'd have an age offset below this. These are charcoal fragments zoomed in. This isn't a lake on the North Slope. It's another project that we have worked on. And so you would take age offsets below and above these charcoal spikes. And just sort of conceptual model on how this may go, the time, older and younger, this is in the sediment record. During the severe fire, you would have a high charcoal flux, which would indicate that severity. And the age offset may be appropriately heightened. Whereas during these moderate fires, it was less so. Both of these indices don't respond as much. The question is how do the fires, how have they changed in the past? And then how common are each type of these? Is there any response? And this can help us test how sort of how stubborn the landscape is in the face of change in this peat buffering hypothesis. So that's what we would like to fill in next. We have some proposal work. We'd like to do this at Lake the Pleistocene and perhaps elsewhere. And we also not only know that climate is changing over this time, we know that fuel change is also occurring. So we have sort of, this is a cartoon version of what we know about the vegetation occurring over this time. Okay, so I should acknowledge there's a lot of people that funded this work. The BLM mainly, with a lot of logistics work and just access to the National Petroleum Reserve, the Center for Global Change at UAF, Park Service, USGS, and the Woods Hole radiocarbon work was done with funding through them. And then some field help and questions. So yeah, thank you for listening.
Any questions for Ben?
This is Alyssa. I have a question. Can you explain why the age offset matters and what it tells us, kind of broadly speaking? Why are we looking at these age offsets?
Yeah, sure. So the age offset is a watershed-wide index for permafrost thaw. We think that when we've done some modern research that shows when permafrost thaws, it releases carbon into the watershed, ancient carbon. It gives us context for a process that we care about today.
Okay, and then just to clarify, when the greater the age offset, the more permafrost thaw is occurring, or do you have the relationship backwards? Yes, no, you have it correct. Think about the duck. So the duck would be older because it would be eating more carbon that was released from the thaw event. Okay, thank you. Thanks for explaining that.
Hey, Ben, I have a question. Maybe you can speak a little bit about when I think you mentioned a date of 10,000 years. Is that when peat really started to accumulate?
Yeah. Well, it really varies. It seems to be generally in the last 14,000 years. Yeah, it seems to take off during the last 11,500 or so. So
I notice it's a year. And do you guys think you can support them for more than a year? I would think so.
I'm sorry?
I'm surprised it's just for a year.
So
I was surprised too. When
everybody needs to go to mute. If you're not on mute, please mute. Thank you.
Sorry. Okay.
I think we're on mute.
So yeah, Eric, that's what we find is the pattern, and that's from work by Dan Mann and Miriam Jones, who have and others who have dated the bottom of that peat layer to infer when it initiated. So that's kind of a rough estimate. And the question is when did it build up enough to become really insulative? And that's work, some of that work is from Carson Baughman, who is at UAF, who shows that it takes several hundred years for peat to both initiate and then begin to start tempering or start cooling the ground, basically, and tempering it from
Okay, I guess the reason I was asking is if you were going to use the past as an analog for the future, you would want to have more or less the same vegetation. In other words, if you want to look at climate change, you want to hold vegetation constant. And you had that slide up there that had the black spruce logs that were 125,000 years old. And I guess that was my other question. I didn't realize there was black spruce on the north slope, but you know that would change your fuel bed and be a complicating factor.
Oh yes, yes. I agree. Yeah, and it may be that the best analog, these other analogs are controlling the conditions to allow us to see what is important. The best analog for the future might be that of a warming event that has occurred more recently when similar existing conditions were in place. And this may be the medieval warm period or something like that. So both methods or both events are useful in their own right, I think. So any other questions?
Okay. So, as I mentioned earlier, Ben has a proposal in with Dan Mann and Ben Jones, and they've put in for a joint fire science project award, and so if that doesn't come through, I guess they have this really great proposal that the research committee thinks is a really good idea. If that doesn't come through, they're going to have this really great proposal that will need a funding source. So if anybody has any ideas on how to get something like this funded, then that would be good information for Ben. So I guess if there aren't any more questions, thanks, Ben, and we can move on the agenda.
Okay, thank you. So is this like a small meeting or?
Basically.
And you're welcome to stay on the line.
Okay, okay.
Yeah, we're kind of a think tank. IARPIC doesn't have any money to give out, for projects or anything, but we're just a group of people that get together to talk about issues in the Arctic relating to wildfire and mostly to connect people, ideas, and funding. So.
Okay.
Yeah, thanks again.
Thank you.
Let's see, the next item on the agenda is a progress report on implementation of milestone 3.2.4.B, consult with local communities and indigenous groups. And Sarah, did I hear that we have Alyssa here? Or?
I am
yeah,
here.
Alyssa's on the line. Yep, go for it, Alyssa.
All right, so I've been pouring through the documents that were put together. Sounds like before I got here there was kind of a collaboration of everybody trying to put together resources for information. And so I've been going through those and going through the meeting notes from a lot of the communities, the subsistence organizations and that sort of thing. And that's what I have been up to. The only kind of roadblocks that I have hit kind of involve my own knowledge. So like I'm reading an article that has to do, with soil biology and that sort of thing and how it changes when a fire goes through. And I then have to kind of go and do a little bit more research because I don't have I've taken soil science classes, but I don't have, any kind of degree in soil science. So I might have to go and then research that further. So that's kind of maybe a stumbling block, so to speak. But that's coming along just fine. And then when it comes to going through the meeting notes, there are just so many and they're so dense and all of that. So it's just taking a while to go through things. But otherwise, I don't see any roadblocks. I do need to touch base again with Todd Brinkman and Sarah Sarah Trainer about when we want to start contacting folks. Because last I heard on that, I was supposed to kind of wait as opposed to try and reach out and start contacting folks on my own. So I have been waiting on that one, but I should get back in touch with them. I still think that we're going to be able to complete this milestone within a year. I don't see that really being a challenge at all. I think that we could potentially be in contact with communities and that sort of thing at the latest by the spring. So that's where I am with that. Questions?
Alyssa, this is Randy. Sorry I got on a couple minutes late, but I'm going to reread the milestone just for folks that might not have the agenda in front of them so they know what we're talking about. It's consult with local communities and indigenous groups on science needs pertaining to Arctic wildfires and their impacts on cultural and subsistence needs. And my question is, do you plan to work with some of the agencies like the BLM, like we were thinking earlier, in earlier discussions about this, Eric Geisler, for example, with BLM and their subsistence coordinator in Anchorage, they're involved with some planning that is going to involve community meetings, and so is that on your list as far as making those direct agency contacts when you feel like you've got a good background rounded up?
I did not know about those meetings, and I didn't know particularly of Eric Geisler, but I will put them on my list. I did intend to get in touch with agencies in general to figure out what was going on, but as of right now, I don't know what different agencies are doing. So it's definitely on my list to do that, but I don't know yet what's going on. So yeah, I'll put Eric on my list and try to get in touch and figure out what's happening so that I can get in on that.
Yeah, for contacts with the indigenous communities, obviously it's really beneficial to leverage a platform that is already in place, a gathering that they're already expecting. In lieu of trying to just sort of make something happen on your own or try to get somebody to reply to your email and they're going, have you ever heard of Alyssa? No.
Yeah. Oh, yeah.
So if there are regional subsistence advisory meetings, or if there are, the Western Arctic Caribou Herd Working Group is meeting, those would be really good platforms to try and get some information.
This is Dave.
Yeah, and Alyssa, I've put up on the screen, I don't know if you're on the WebEx, but I've put up on the screen Stacy Fritz's page. Stacy is with BLM, and you'll see she's posted a report on a subsistence advisory panel meeting from February 2015, and I know she was on a meeting just a day or two ago of the communities group, and she said their newest meeting from the summer is now out as well. So Stacy Fritz would be an excellent point of contact, and she's very familiar with IRBEC.
Awesome.
Yeah, this
Thank
is Dave.
you.
Can you hear me?
Yes, I can.
Yeah, I was going to bring up Stacy Fritz. We're planning our next NPRA Subsistence Advisory Panel meeting in Anaktuvuk Pass, which is the community that responded the loudest about the Anaktuvuk River Fire. And having a little hard time scheduling that meeting, but I think it's going to be the week of the Martin Luther King holiday.
Okay.
It's not determined yet, but that would be like January 19th.
Okay.
And a few days thereafter. And I don't know if you're interested in traveling to Anaktuvuk Pass, but if you are, Stacy might be willing to put you on the agenda.
Awesome. Thank you. Yeah, that'd be fantastic.
Another person that I think you should connect with, and I think is on the line, is Vanessa Skeen. Vanessa, are you there?
I am.
Yeah, so Vanessa is with USGS, and she's working on a milestone that's also related to, traditional and local knowledge for the terrestrial ecosystems group. And I think, Vanessa, you have a session at the Alaska Forum on the Environment on this?
Hopefully. We still haven't heard back from the coordinators, but we're hoping to have a session at AFE, which is in February in Anchorage.
So I would just suggest that the two of you check in together, because I do think this work is very complementary, and probably making sure we're well coordinated would be a good idea.
Sounds great.
Well, this is Dave again. Just one note that Stacy Fritz is going to be going on vacation next Wednesday, and will be out until December 10th.
Okay. I'll make sure and contact her before that.
All right.
Thank you for all that help, everyone. Appreciate it.
That's what we're here for, I guess. Let's see. I have, next on the agenda, maybe I don't have the right agenda, but it says progress report on, March workshop. Okay, so that's, that sounds like Randy here.
Right, and Allison's on the line too.
Okay.
The last time I checked Inspires a couple days ago, everything looked copacetic as far as our submission, but there was no new information on anything, hearing back from NASA yet on the opportunities to apply remote sensing and fire management science workshop that we'd like to have March 9th and 10th in conjunction with the ASSW 2016 in Fairbanks. Allison, you know anything else than I do on that?
No, I don't, Randy. I'm sorry to say. But yeah, we need to, you're going to be talking with people when you're at the Association for Fire Ecology meeting next week in San Antonio, hopefully drumming up a little interest from the attendees at that meeting about this workshop coming up. And we'll, over the next month or so, and I think we'll be able to report more at the December meeting of IARPIC about progress that we've made on, we'll be working on agenda development a little bit, I think, in the coming month, and thinking about some specific issues that we need to talk about at the workshop.
Yeah, so Alice and I have been kind of like debating on how hard should we start advertising this, because truly it's not that far off when you think about budgets and travel plans and scheduling with a lot of really busy people to make it to the workshop. We could use some advice from some of you guys like Liz or Laura, who maybe been through this process before. We don't really know exactly what the timeline's going to be, and whether we should advertise as though it's going to happen or not.
You know, this is Liz. I'm not entirely sure about that. I do know you want to get the word out as quickly as you can, and I know that people can start to sign up for Arctic Science Summit Week now. So I can ask back, but I don't know anything about the Inspires process or when you'll hear about that or not. Sorry.
That's okay.
Has anybody done a workshop this way, got funding for a topical workshop through the NASA process?
Is there a program manager listed?
Can you hear me?
Oh, go ahead.
We can hear you, Christina.
Okay,
Go ahead,
I hope I wasn't talking over somebody. So this is Christine Mataya. I work in the Earth Science Division where the program that you applied to sits, but don't work as closely with Lawrence Friedel, who's the Associate Director. I will see, I cannot promise that I will get any information, but I will try to hunt it down within the next several hours. I'm going to be away for several days and won't have access. I'll be out of the country. What I know, and whether or not that it turns out to be true, is I believe with the process that you've applied for, it should be a pretty quick turnaround. But then again, you know, with any bureaucracy, you know, things get delayed and other things come up and push back decisions. So I think in theory, you should know pretty quickly in general after you've submitted. But let me see what I can hunt down, and then can, you know, let you guys know from there. But I just realize I may not get an answer for you.
That'd be great, Christine. Thank you.
You're welcome.
So this is Sarah. I have a question because I know that room space for ASSW is getting very tight. Have you reserved the space in case you have? Okay, great.
Yeah, we should be good on space.
I wouldn't worry too much about the advertising because there are going to be a lot of people in Fairbanks for AFSW and the related meetings. So, you know, once you know, I think you can get it up there and it will go out to a lot of people very quickly.
Yeah, I think
that's what we were hoping. That's why we pushed to have it during the same period. Although we're actually having it before ASSW week, so because the 9th and 10th is just before. But I'm curious, who on the call is planning to come up for that?
This is Lisa. I'd come up for it. Wait, for the remote sensing thing if we get it, or the whole other?
Yeah, either or, yeah.
I'd definitely make it to the remote sensing one. I'm not sure about the rest of it though beforehand.
This is Liz. I'm interested in both of them, but I've got to see what my travel schedule's looking like then.
And this is Laura. I'm interested in both of them also.
Great. Well, I plan to talk to some more people at the Association for Fire Ecology meeting next week, like Allison said, and just sort of put the word out person to person and through the grapevine. And yeah, hopefully sometime this month we'll hear something, because then we'll have to start the selection process for travel honorariums. So we'll have to fire up our committee, our advisory board, for the proposal to make those selections, and that's going to take a little bit of time. So I think that's all we got, Eric.
Okay. Item 5, updates. Do you have any updates on anything?
Eric, this is Allison. I just have want to let folks know that Alaska Fire Science Consortium is hosting 2 webinars in the coming weeks. There will be one next Monday by Casey Brown, talking about her work on moose habitat in post-fire environments. Sorry about that. And then Scott Geyer on December 2nd is going to be talking about using unmanned aerial systems for monitoring work through the DLM AIM monitoring program. And the information about both of those webinars is up on the Alaska Fire Science Consortium website. So let me know if you have questions.
Okay, thanks, Allison.
Allison, I can post those on the IARPIC website too.
Good idea, Randy.
Okay.
Did I hear somebody else with a comment?
Same comment, so thank you.
Okay. A couple items, I guess. Ben mentioned that paper by Ben Jones, and I posted that to the IARPIC site this morning, so if people are interested in that, there's a link there. And I have an update on Dave Gustine. Just heard back from him this morning. I was having a hard time getting a hold of him, and he's pointing the finger at Kyle Jolly, so I'm going to see if I can get Kyle Jolly to present either December or January. We'll see if we can get Kyle. And then, does anybody else have any ideas for speakers? People can keep their ears out for people that might be able to speak to some of the topics we're interested in here. So, let's see. I think that's all the items I have. Anybody else?
Eric, I had a question. I had a question, Eric, about the Kyle Jolly presentation. What was the topic there?
It was about caribou use up on in the porcupine and the Arctic caribou herds, and relating to fire. And that was a paper that came out by, the first author was Dave Gustine, and Lane Adams was the last author, and I guess Kyle Jolly was in there somewhere as well. So, and actually what I can do is I'll post that the link to that paper on the IRPIC site also, and people can look for it there. Anything else? All right. I guess the next meeting is December 10th. And thanks, Ben Gaglioti, for presenting, and thanks for participating, Alyssa. So, if nobody else has anything else, we can convene till next month.
Thanks, and I'll post the link to Ben's presentation probably early next week, so it'll be up there. But his slides are already available on the site.
All right.
Thank you, everybody.
Thanks, Ben.
Thank you. Bye.
Thank you.
Next time.
Thank you. Bye. Bye-bye.